Hello friends, welcome to my channel Simply Nearing. I am here to explain briefly about what is happening in the chill water system, how water flows between the chillers, primary pumps, secondary pumps, AHUs. In this video, I am going to explain about the working of primary pump, what is the work of primary pump, what is the work of secondary pump, how AHU works, how water flows, how the chiller system works, what are the valves used in between. All these things we are going to discuss. To simplify this layout, very often we will come across this common question for HVAC project engineers to draw the layout of chill water system. Here we'll take one sample project, air cooled chiller. So for Gulf, Indian and European interviews will come across this question: how the chill water piping system, draw a layout of a chill water system. So here this layout I have divided into 4 parts. One part is primer system, second part is chiller, third part is secondary pumps, fourth part is air handling units. First of all, when system runs, what will happen? I am going to explain. Once the system runs, the primary pumps the water to the chillers. From the chiller, water will get cooled down and it will come water to the secondary pump. Secondary pump sucks the water and it will discharge the water to AHU. In this AHU, we have motor, fans, blowers, impellers. So this air, this water flowing in the evaporator will touches the air, and air temperature will get decreased. So then the water again it will come back to the primary pump. This primary pump sucks the water and discharge the water to the chiller. This is the system. So let me briefly explain you. Here in the primary pump, first we have flexible connector. The use of flexible connector is to absorb the vibration in the piping, noise and vibration in the piping. Then pressure gauge. Pressure gauge is to give the pressure in the inside the water inside the pipe. Non-return valve or check valve. Non-return valve or check valve used to flow the water in only one direction. And double regulating valve. Okay, this is double regulating valve or balancing valve. Double regulating valve and balancing valve is to balance the water flow or balance the GPM. In every system will have some GPM. See, the system once we will get for every tonnage of water will have a certain GPM in the system. We have to maintain the GPM. To maintain the GPM, this balancing and double rating were used to maintain the GPM. And this butterfly valve at the end. Butterfly valve or balancing valve is to regulate the flow of the water. Regulate, open or close the system. In every system end we should have butterfly valve, because if this primary pump or any pumps will have any technical or mechanical issues, we can isolate the whole system and we can run the system without this primary pump. If this primary pump is in this 2 working and 1 standby, if in this three pumps any pump having problem, so if we cannot use this pump, so we can just close the butterfly valves here and here, both in suction and discharge side, and we can with the other 2 pumps we can run the system. So this is the main use of this butterfly valve, to regulate the flow of the water. From the primary pump, the water will go to the chiller system. Here the chiller. In the chiller system, first we have the isolation valve. Isolation to regulate the flow of the water. Wide strainer. This wide strainer will strain the solids from the liquid. The water will have some contaminants. In this wide strainer having the mesh type of arrangement. This arrangement will filter the solids. Automatic air valve, air vent. Air vent is an air release valve. In our system we have some air inside the system, so these air vents will release those airs and maintain the pressure. And we should have temperature gauge and pressure gauge and flexible connection. Flexible connection is to absorb the vibrations and noise of the pipe. Then chiller, water flows inside the chiller. The water entry temperature inside the chiller will be 11 to 12 degrees centigrade. After that, the water will get cooled and will come back. And the return temperature of water will be 6 to 7 degrees centigrade. This is standard. So, return. Here we have the walls for the return. In the return, first we'll have flexible connector, pressure gauge, temperature gauge, double regulating valve, motorized butterfly valve, isolation valve. From the return, chiller return, the water will go to the secondary pump suction. In the secondary pump suction, we have butterfly valve, voice strainer, pressure gauge and flexible connection. Here I have written clearly flexible connection. This secondary pump will discharge the water to the AHU. First we have to think what is the use of secondary pump and primary pump. Secondary pump, here this primary pump will pump the water to the chiller. This primary pump usually having small head and small power and compared to secondary pump, because this primary pump is pumping the water to the chillers only. This head of the primary pump is the difference between the primary pump, bottom of primary pump to the chiller supply line. This secondary pump head is more, because this secondary pump is pumping water to the AHU till the AHU. So how to calculate the heads, how to calculate the primary pump capacity, secondary pump capacity, this I will explain in my next video. How to calculate chill water piping sizes, this I will explain in the next video. Here from secondary pump, this pump discharging water to the AHU. Here we have flexible connection, pressure gauge, non-returnable valve, double regulating valve and butterfly valve. Then the water, this secondary pump will pump water to the AHU. Here see, this AHU connections, I have made a separate section here for this AHU connection. For this AHU connection, water inside first we have butterfly valve, then will come voice strainer, then temperature gauge, pressure gauge and flexible connection. Then water will flow inside the operator of the AHU. Then return flexible connection, pressure gauge, temperature gauge, two-way valve, automatic air vent. What is the use of two-way valve? The use of two-way valve is, see, this AHU, we are providing this AHU, from this AHU through the duct, water is this air is going to the room. Okay, in this room we will set one temperature, for example 24 degrees centigrade. To achieve this 24 degrees centigrade, this is an internal BMS system. This two-way valve will works with the actuator. So once, for example, in the room we have only we have 30 degrees centigrade, again it has to come down to 24 degrees centigrade. So what will happen? This will give command, this thermostat inside the room will give command to the two-way valve. This two-way valve, what is the use of this two-way valve is, it has an actuator. It will allows, for example, if the 24 degrees temperature is allowed, this two-way valve will close here. Once temperature is set, the two-way valve will not allow the water to go back. So the entire system, so due to this back pressure, the secondary and primary pumps will reduce the speed. This is the main use of this two-way valve. Two-way valve, this BMS system, how the two-way valve works, how the primary pump, secondary pump, VFD works, how AHU VFD works, this I will explain in the next video. This two-way valve is like it has a two side walls. It has two side walls. So this two-way valve, main use of this two-way valve is, once the temperature set, this will close. It will not allow the water to go back to the chillers. So what will happen? Due to this, the back pressure will develop. Due to this back pressure, there are differential pressure sensor in the primary pumps. This differential pressure sensor gives the command to VFD. Due to the differential pressure, this VFD will regulate the speed of the secondary and primary pumps. So in this, by this we can reduce the speed of the secondary and primary pumps. Therefore, we can save the power. So this is the main use of this two-way valve. Two-way and three-way valves also we can use. In the some of the consultants will ask for three-way valve. So I'll explain how this two-way, three-way valve works in my next video clearly. So in this video, just I'm explaining about the valves and the whole system piping, how the whole system works. This I am explaining. So an automatic air vent, then butterfly valve. Then this from the AHU. From the AHU again the water will come to the primary pump. So this is an closed loop. This is an closed loop. Again from primary pump water will go to the chillers. Here chillers. Here I have small notes for you. See, butterfly valve. What is the use of butterfly valve? To regulate the flow. Why strainer? It's a mechanical device, mechanical removing unwanted solids from liquids through wire mesh straining system, straining element, pressure gauge to measure pressure of the fluid, temperature gauge to measure the temperature of the fluid, flexible connection to provide driving system with flexibility needed to observe noise and vibration. Check all non-retaining wall. It allows the fluid flow in one direction. Double regulating valve to balance the flow of water to maintain the GPM of water. Automatic air vent or air release valve to release the trapped air inside the system, maintains pressure in. So this is the whole working principle of chill water, air cooled chill water system. Thank you friends, thanks for watching my video. So in my next video I will explain you how the PMS system for the chill water system works, how to calculate the head of secondary and primary pumps, how to calculate the size of chill water piping, and I will explain you the formulas, how to calculate the TR, how to calculate the GPM. Kindly subscribe to my channel and press the bell button. Thank you.